Hey, I have here today a homemade integral. This one is going to be the integral from 0 to 1, x to the minus 1/3, 1 minus x to the 1/3 dx. Okay, and when I did this, I really did this with the method in mind before I came up with the problem. And what I want to use is going to be the beta function. So we have our formula for the beta function over here on the right, and what it does is we have an integral with the same bound, same form, and it allows us to get our solution in terms of the gamma function, which hopefully is going to be easy to calculate using factorials. So we'll get right into it. I'm going to try to solve. We need our z1 and z2 value. So for z1, we're saying this minus 1/3, z1 minus 1 equals minus 1/3. That's going to mean that z1 must be 2/3. And then similarly for z2, if you notice that if z2 is 4/3 and you subtract 1 from that, you get back 1/3. And so the nice thing is we can kind of go right to our answer. These usually go pretty quick. So we're going to be looking at gamma of 2/3 times gamma of 4/3 all over the sum of these, but we add these two together, we get 6/3 or gamma of 2. But we'll use this formula here. Gamma of n is going to be n minus 1 factorial. So gamma 2 is 1 factorial, but that's just 1. Then I'm going to focus on just this gamma of 4/3. Now because gamma of 4/3 can be written as, using the factorial, this can be written as 1/3 factorial. Well, then we can kind of just take this last formula in reverse. 1/3 factorial is going to be the same thing as our n times gamma n, so 1/3 gamma of 1/3. And so what I'm going to do is we'll take that and put that back into our equation here. So rewriting this, we have gamma of 2/3. Gamma of 1/3. I'm just going to bring this 1/3 out front. Okay, but here we still have a problem because each of these, gamma 2/3 and gamma 1/3, is not so easy to calculate. Gamma is actually easy to use for integers, and it's also easy to use for pretty easy to use for half integers, but not thirds and sixths and other things. So what we're going to do here is use Euler's reflection formula. Okay, so we have the formula we want to use over here on the right, and you'll just notice we're in the right form here where we have the inputs 2/3 and 1/3 equal 1, and z plus 1 minus z equals 1, or however you want to look at it. And again, of course, the order doesn't matter, right? We could have the 1/3 here and the 2/3, or the 2/3 in front. It doesn't really matter. So let's calculate this. We're going to have our 1/3 out front. Then we're going to use this. We're going to have a pi in the numerator. And then again, we could use 2/3 or 1/3. Let's just use the 2/3. So we'll have sine 2/3 pi. Now for this sine value, this is actually going to be square root of 3 over 2. But what I'll do is I'll take this 2 into the numerator, and we'll have our pi. And then I think all I need to do is I don't really need this 1 here, so we'll remove that. And that's it. So our solution is just 2 pi over 3 square root of 3. There you have it. Thanks everyone for watching. Have a great day.